Hello, can you hear me? Hello, can anybody hear me? Hello? Yeah, yay! I can hear you.
I can hear you.
I can hear you.
Who else is there?
Just me.
Just you. The people?
No, there's no one on the attendee list yet, but I am recording just so you know, so FYI.
Why are you recording?
Hello. Can anybody hear me? Oops. Can anybody hear me now?
I can hear you.
Awesome. Okay. There's all these new little buttons I have to press now. So how are you today?
Oh, great.
Good. Oh, let's see. Where are the slides? Okay. Now let's make sure I share my screen this time.
Can you hear me?
I can hear you.
Oh, I was trying to figure out how to put this on mute so you don't hear me eating. Let's
Oh, let's see. Wait, where did my Zoom window go?
see. Oops. Audio, okay. Let's see.
Wait, do you see my screen at all?
Yes.
You do. Okay.
Yeah.
But it says sharing is paused. How did that happen? Okay. Cool. Ooh, it looks like we have a couple of people on the line. How's everybody doing oh wait, hold on. Sorry. I was told how to do this and I can't remember. Okay. How's everybody doing today?
Great.
Good. Doing good.
Awesome.
Yay, hi.
Hi. Welcome, welcome, welcome. Okay, before we get started, I'm going to just do a little bit of an intro. We are going to go over chapter 3 in the Automate the Boring Stuff book for Intro to Python. But before I get started, my name's Jamila. I'm just hosting this session today. By no means am I an expert, just helping us all learn together. But just a couple of things about Women Who Code before we get started. Does anyone have any achievements they would like to share with the group? Because we like to try to make sure that we recognize things that people have done. So anything that you want to applaud yourself for or applaud someone else for? Okay. Different question. Did anyone read chapter 3?
I did.
Yay! Achievements! I don't know about you, but like half the reason I joined the study group was to make sure that I accomplished something with Python. I keep wanting to learn and I never did. So I finally read chapter 3. So I feel like that's an achievement. So kudos to anyone else who did.
And you should be especially proud of yourself for getting through chapter 3, because I think I know for me personally, functions were a bit to get my brain around when I first learned about functions and what to do with them. So and that's what this chapter is all about. So sorry, go ahead.
I said I agree.
They are.
I agree.
Definitely a different way of thinking. Okay, well, next time we're going to do another applaud her. So think about any achievements that you might have accomplished since the previous week, and we will definitely acknowledge those. Let's see, what else do we need to talk about? Oh, well, this is great. I'm going through the slide deck backwards, so I am not, hold on a second. I was wondering why that came so soon. Okay, so our mission as Women Who Code, it's a global nonprofit just dedicated to inspiring women to excel in their technology careers, whatever that might be. So notice it says technology. That's not necessarily about, it doesn't mean that you have to be a coder all day long. And in fact, it's not like we're gatekeeping and saying that you can't be a part of us if we're not in technology, but that is our focus. So promoting technology as much as possible. So we're here to empower, educate, hopefully gain some role models and support in a global community, especially since we are a global track. So we hope to have members that are like all over the world. So that's going to be really awesome. Code of conduct, just always want to mention this. We are an inclusive community. There are no judgments, no gatekeeping. Does not matter what your background is, whether that's race, gender, sexual orientation, religious affiliation, any of that. I like how they included preferred programming languages here. Even though we study Python, it's not like we're hating on anybody else. And so just keep that in mind. We want to make sure we stay inclusive going forward in everything that we say and do during this webinar. So with that, go to womenwhocode.com if you are interested in becoming a leader, if you're looking for some coding resources, looking for a job, any of these things that you see here are available on womenwhocode.com. And there are a number of tracks out there. There hopefully is a local place near you, but we are the Python track. But if you have an interest in something else, I know a lot of people in Python are also interested in data science. So there is another one out there for you. If you go to the womenwhocode.com website, you'll be able to find that information there. And the people who support us financially, giving us resources to help make this all possible. So we just wanted to give a shout out to those individuals, McKinsey Company, Python, Home Depot, and of course, Women Who Code. You're welcome to get involved. You can go to our website, but probably the quickest way, if you really want to find out ways that you can get more involved, is you can just go to our leadership channel on the Slack. There is a leadership channel, so if you want to see what we're up to, or if you want to get involved in becoming a leader as well within Women Who Code Python, please feel free to come and join us. If you haven't already followed us, be sure to do so on all of the local social media options, Twitter, Facebook, and Instagram. And just as an FYI, if you're not already aware, we do have a Python Track Summit coming up. So in case you're not sure what a summit is, it's just a conference, except it's a one-day conference. It's going to be in Atlanta, Georgia. So hopefully you might be able to see some of us out there. Instead of us being all virtual, we can see each other in person and say hi to each other and learn some Python. Okay, Now we're back to the slide. Now we can get started into chapter 3. But before I go on, was there any questions about what I just sped through? Anything? Okay, awesome. Well, then let's go ahead and jump into chapter 3. What'd you think, guys? How'd you like chapter 3?
Well, I liked it because, like you said, he simplified the concept of the function for me.
He did. Oh, did you get the book?
Yes, I got the book.
You were working on getting the physical book, right? Is it easier now?
Yes, it's much easier, and the spacing and indents are correct in the printed book.
Awesome. So good to know for everybody else who might want to get the printed book.
Yeah, 'cause that's starting to drive me nuts. Like the print, it being off just like half a space. Yeah. Makes me crazy.
It's one of those things, well, you know what? I'm not even going to say that. I was going to say how hard could it possibly be, but apparently it is a little bit difficult to get it. Okay.
You know, earlier in my career, I was a software quality assurance person. I tested software, and you would not believe the shenanigans when it comes to different screens, different mediums, different browsers, and different font faces.
Yeah.
It's kind of amazing sometimes that things look as good as they do. So.
How did we get here? Well, that's good. I'm glad. It's probably because of all those software quality assurance people out there helping us out.
And all the engineers and all the people who are excited about learning to code. I mean, it takes thousands and thousands of people. So yeah.
Woohoo. So that's a good point. The worst that we have is a couple of spaces off here, so it's not too terrible. Okay, so who would like to describe? Okay, so I'm just, as you know, as a goal, I'm going to try to make sure by 5:40, excuse me. Well, it's 5:40 my time. 40 after the hour for wherever you are. I'm going to try to make sure that we're about where the questions are. That way we have enough time to answer those questions and work through our programs and stuff. So I'm just going to keep an eye on the time. Cool. So who would like to describe, how did you feel, like if you were to describe what a function is, what would you describe it as?
I would say a function lets you group code that gets executed multiple times because you do not want to duplicate code.
Perfect use of using the function. I like it.
Yeah, that's an excellent definition. And I think the only thing I would add is that you can name it for later reference.
Right. So it's probably important to make sure you keep that in mind when you're writing it. Don't just name it, function 1. Name it something that's relevant to what what's hopefully happening inside of that function. So
yeah, a little mnemonic.
Yeah. Here's sort of an example of what a function looks like. If you're not already aware, we're going to just define it with that DEF. Then you have the little brackets, and then you have the colon. What are the brackets? The parentheses, followed by the colon. And then everything inside of the function is indented a little from the left-hand side. Now, this is a definition of a function. Wait, can everyone see my screen?
Yep, I can see it.
Okay, good. Just want to make sure. I remember last time I kept talking and no one could see what I was talking about. Okay, so this part right here, that's our function definition. So what are these guys here, number 3?
Inside the parentheses, it would be the argument.
What would go inside of the parentheses? Yes, what inside of the parentheses is the argument. But do you see here where it says number 3?
It's the function call.
Function call, yes. So these aren't functions themselves. It's when the code gets to this point, it says, hey, go find this function wherever it's defined and run that code. So we come all the way down here to line 3, we come up here to hello, and then we start running what's inside of the function each time it's called. So we have the definition of a function and the function calls down below. In this case, they're down below. Cool. So that's how we basically create a function, and then it just keeps going on from there. I think one of the key things to remember about those functions, you can put something inside of the parentheses. And I think I never picked up on this before when I was learning it. What is this called? What's inside of
Parameter.
parentheses? Parameter. Why not argument?
The argument is what is in the parameter.
Well, yes and no. I would say that for better or for worse, those terms get kind of slung about interchangeably, especially when you're calling a function where you pass a parameter, and then when you're defining a function, the variables are the arguments. But I've heard both for both, and so I tend to kind of interchange them. But you're right. One is an argument, but then when you call the function, the value you are passing is a parameter, right?
Wait, I think it's the other way.
Is it?
Yeah, I think, so let's see, hold on, if I'm reading this right. When you call this function, you pass the value. So what you pass is the actual argument. So here, that's the argument.
That's the argument.
Yep.
Yeah, but what makes it more confusing is there are args and quargs, which we're getting ahead of ourselves, but args and quargs actually go in the definition as opposed to being in the, well, they go in both, but yeah, the arg star and the quarg star go into function definition. So I like I said, I use them interchangeably.
Well, I think that is probably the important thing to remember, is that I think I've heard them all the time interchangeably. So if you hear argument versus parameter, just know that we're talking about what's inside the parentheses for a function that you're passing.
But your distinction is really important. So when you're defining a function, the things that go in the parentheses are placeholders. They're variable names.
Right.
Whereas when you call a function, you're calling it with values that the function expects.
Agreed. That is a good point.
Yeah, I think that piece is that point you made is really important.
Okay. Did we confuse anybody? Everyone good on that point?
Yes.
Okay. If you don't stop me, I'm going to keep going. Okay. So returning values and in our return statements. So it's just basically a way to break out of that function and give it that particular value that the function was trying to evaluate. So it could be a number of things. In this particular case that we have in front of us, this was the random number generator thing. It gave us a fortune each time we put in the number. So someone put in a number, and then based off of whatever that number was, the function returned a very specific string in this case. It could have been a string, it could have been a number, or a value rather, but return is just what the function essentially evaluates to and returns back to whatever portion of the code called it originally, and just continues on. Any commentary about returning?
The thing that bites me even today is that two things. One, if I don't return something out of the function, once the function stops executing, then I lose all the data inside the function.
Yes.
If you cannot exfiltrate what the function's doing, then once the interpreter has passed it by, it's gone forever. And then the second thing, which I think we'll go over in just the next section, is if you do something like print or some other call or assignment inside your function, but you do not have a return statement, the default return for any and every function, if not otherwise specified, is none. And that has bitten me a couple times.
Okay, I'd like to follow up on that, but let's hold on to it when we get to that section. Sure. So yeah, I think the key here is make sure you return something. If you're trying to evaluate something, you want to use it later, make sure you return it. Any other questions or comments about returning? So this one, none. This is weird for me, I guess, because I've never thought about this at all. Like, understanding null, the concept of null, I understood, but like the fact that the print statement actually is returning a none value. I guess at the end of the day, it became, why do I care? Like I've never encountered that, but I've programmed very limitedly. So can you explain sort of like why you even care that a function returns, like why print returns none?
So the way I think about it to myself is, if something's going on in that function and something goes wrong and I haven't captured the problem, how do I know the difference between something happening and the program suspending versus the function completing as it should, even if it's not returning anything to me? And so none, which I think frustrates a lot of programmers coming from other languages, is Python's way of saying, oh yeah, I did that. No, there wasn't a problem. Everything's okay. So the function completed, it's just, I don't have anything to give back to you. And in other programming languages, Go is one of them. What might happen with the return from a function is you get either the value back or an error. And so there's this pattern in the Go programming language where you're always checking to see whether or not you got an error back or you got what you wanted. Python does this little thing where it says, none, like I didn't cough up an error and everything happened okay. But that's me kind of explaining it to myself. But that maybe would be why you'd care, is that it's telling you the function executed even though you don't have any obvious evidence that it did.
Okay, I will keep that in mind because I feel like that might be something I would use in a more complicated scenario. But yes, good to know. And sorry if you saw me doing something on my screen. I think the way this is set up, you're not allowed to speak unless I let you speak. So I was just allowing everyone to speak. So if you've been trying to say something and you couldn't, just know that I turned you on. So you're good. Okay. Any questions about this before we keep going? Okie doke. Then key arguments and print. It was sort of weird this was thrown in here, I guess, just because we talked about print in the previous chapters. But I think the key here was just knowing that when you print, it automatically goes to a new line. So it has this ability now to allow you to add inside of this, oh, I guess that's why, because it's about functions, allows you to say how you actually want the print line to end. So if you want it to end, if you don't want that new line to show up, you have to add this little end with an empty string as an argument to this function. Or I think the other one was called a separator. So you can put like little commas or spaces between everything. So that was a fun little thing to find out.
That is a fun thing, and another fun thing about that, so that's particular to print, but another interesting thing about Python is parentheses are a little bit magic. Python will implicitly concatenate, meaning string together strings that you put in parentheses. And so every once in a while you will see someone use that trick in a return statement to concatenate something without actually concatenating it, which is a little weird, but I have seen that. It'll just say, oh, well, you must have meant to group these together because they're inside the parentheses. So kind of together. Yeah.
Learn something new every day. Crazy.
Weird corners of Python.
Okay, so now we're going to get into variables and the scope of variables. This is where it gets fun. Okay, so I've been talking a lot. Does anyone want to describe like what we sort of learned in the global versus local scope and like what the differences are between the two? Oh, you know you want to.
Well, they said don't use global variables. It's not recommended to use global variables.
But why? Why wouldn't I want to do that?
If you have a really long code and there's an error, he said you'll have a hard time identifying the error if it involves a global variable. So he said use local.
So yes, it can be hard to find it. If we throw some context around the difference between a variable at the global level and a variable at the local level. So a variable at the global level is defined, I'm sorry, were you going to say something?
It's the global is for the whole program, whereas
Right.
local is just for smaller chunks of your program.
And specifically, like, so the local variables are specific to a function, right?
Right.
And Bethany, please feel free to correct anything we're saying.
Well, I was just going to say global, right? So there's a difference between, say, a nationwide or a worldwide broadcast on television and your local news station. And when something is broadcast globally, the same message goes out everywhere. So everyone hearing that message hears the same thing. Mm-hmm. Whereas locally, it may only be the people right in the vicinity who hear whatever's going on.
I love that analogy. I'm sorry. Go on.
I'm sorry, go ahead. No,
I love that analogy because I was trying to think of a good one in real world, but yeah, go ahead.
Yeah, so the problem comes, to kind of stretch the analogy maybe further than it should, when somebody does a global conference and says, such and such is going to happen. And then the mayor of a small town sneaks around and says, no, that's not really going to happen. And you have a disagreement. And you can't actually have a disagreement. So that's the problem, is that a global variable is the same for the life of the program throughout for every piece of the program that calls it. And so if it gets changed everywhere simultaneously. So it literally is global. It coats the whole program. Whereas local scope, as you said, is only pinned to a block of code, a class, or a function. And those change locally. And so the reason it's a bad idea is that you never want to get lost and have those things come into conflict, because global will win, and you may not want that, right? You may want to be able to make local decisions.
Right. So I'm sorry if you saw me scrolling back and forth. I was trying to find an example in his code, and I realized there wasn't a good one soon enough. But here's an example of, you have a function here, and here is a variable being declared at the global level, not within the function, but at the global level. So it's outside of a function. So first of all, that's why we have, why am I blinking?
I think a recording is on.
Oh,
so
okay.
Recording this session. That's what it's showing up on my screen, as it's blinking and it's saying recording.
Okay. None is just a value. Oops. Didn't check that soon enough. Okay, I will come back to this, Lori, about the none, about the none thing. But thank you for chatting that to us. Okay, so when we're talking about this global variable, it's declared here at the global level, and so it's alive here, and it can be alive here inside of the function itself. But
right.
this
So,
is actually,
so the function can access the global variable. But yes. I think if you scroll, there might have been an example further down in the chapter where you scroll where there's a problem where you get an error because you
yes.
try to, yeah. Right. So one of the ways to keep this straight is Python has this keyword called global. So if your intention is to actually have global variables, but then have your local variables modify, then you have to tell the interpreter using global that that is what you intend to do. And if you don't, then Python's going to say, no. The global says this, you can't disagree.
Okay, I'm so glad you said that. The key on that, what I just heard you say, was this keyword here of global. When I'm using this global variable, was my intention here was to modify it, not necessarily just use it. So if you notice up here with this one, the function is actually just printing the value, but it can do that. Right? That's not the local version of eggs. That's the global version of eggs. But because we haven't modified it or anything like that, it's still referencing the global one. If I was intending to modify it, I have to throw the global on the front. Is that correct?
Yes. And if you don't do that, I think a little further down, there's this error statement that says variable was referenced before assignment.
Yes. Quite further down. There we go. Here we go. This is an example of
unbound local error. Local variable was referenced before assignment.
So the global variable was assigned to global, then they tried to use it here, but then it notices it tried to, within the function, assign it, and that's where Python was like, nope, not allowed here.
Right, and that's because the interpreter, and I think he'll go over this maybe in later chapters, but when a program is read in by the interpreter, things happen in a certain order. And so one of those things is that values get read, values of variables that are global get read into the global scope, but values that are local don't get read in until the interpreter gets to that function definition. And so it's kind of saying, hey, wait a minute. I already have something, right, that says it's eggs, but now you've turned around and you're trying to do it again, and I don't know what you're talking about. Like, I don't know which one you're referring to. Anyway, that's further down the line. But yes, there's like the worldwide, and then there's the piece by piece scope.
So that's the key on global variables. When you're using local variables, here we go. An example of local variables, that's a variable that you have defined inside of the function itself. It only lives as long as this function is executing. As soon as you leave the bounds of this function, it basically disappear. All the variables inside of it, the values assigned to the variables inside of it disappear. And so if you go and you try to call it again, it's just going to restart back at the top and reassign, in this case, eggs to number 99. So just be careful keeping that alive. Like, local variables only stay inside of that function as long as that function is running. As soon as it stops running, poof, you have to start over.
Yeah, and so you'll see further down the line that there are functions that play off of this, where you will have a variable that you know on purpose is global, and the function will assign values to that variable that's outside of itself so that you can kind of keep track. And that's a really common pattern until you learn the next step of how to kind of put things together in classes and persist things longer. So, exception handling.
Looking forward to that. Now, before we get into exception handling, I think one of the key things to remember about function, and this just might be a keeping your code clean type of thing. I've always learned, or maybe it's just my preference, I do not like naming my global variables the same thing that I would be naming at the local level. Just because that gets a little too confusing of keeping track. Even though you can, doesn't mean you should. So try to keep your variable names, make sure they still make sense for what you're trying to do, but don't name a global variable the exact same thing that you would name a local variable. It's just not nice to humans.
And that's it exactly. Be kind to your future self, and don't do it.
Future self and other people too, because if we're ever programming for other people, right, they need to be able to understand it just as well as you feel like you can. So, okay, before we get into exception handling, sorry, one more time. Any questions since we've just been talking like crazy? Anyone want to interrupt, correct anything? Okay, why do we do exception handling?
For the same reason we name our function definitions and variables things that are nice, because we want to know what's going on and we want other people to know what's going on.
Yes. It's the worst in the world. You go into your little function and you get this back. Like, it just errors out on you. And then I think it's not just the error out part that's bothersome, it's the fact that it didn't finish the rest of the program. So in this particular case, it was trying to actually divide two numbers. So notice, just to break this down real quick, here is the global portion of it, and then here's the function definition here. So it was calling this function called spam, passing in the number 2, and so it's dividing 42 by the number 2 that got passed in. So you can divide 42 by 2, no problem. You can try to divide 42 by 12, no problem. But as soon as you try to divide by 0, we have a problem. That's not allowed. And so it throws this error, and then it just stops. It never tries to do that last piece. So error handling, and if you know anything about my background, you know I like to care about user research and, making the user experience nice. This sucks if you're trying to make the experience nice. If there's more code that could run and not have a problem, it's not doing it because we're not handling any potential problems with this code.
Well, and also if that error has been inadvertently caused by a user, crashing and giving them a bad experience doesn't help give them the feedback they need to avoid the behavior. And so that's another reason you would want to handle an error, is to give a message back to the user that you were looking for a different input or something else.
Ooh, great point. So it's not the greatest to read. This is actually pretty understandable, but sometimes they're not this easy to understand. So as you were saying, you can put a human, a human readable error on the other side so they know what to fix. So that's what happened here. They did the same little print thing going on down here, still try to divide by 0. But what they did was for the division, they put that in a try. And so we're going to try to do this, but we know that there could be a problem. So we're going to do this except when this error is encountered. If you ever encounter a divide by 0 error, then print this to the screen. Instead of all of that funness that we saw above, it's actually going to say invalid argument. Or it could say whatever it is that you want it to say, because this is literally what the human is reading. So this is now the result. And notice how it continues dividing after the error was encountered.
So he has simplified this a little. These are all the important parts, the try and the except. But Python also allows you to do a finally. So you can do a try, you can do something in case an error is thrown, and then you can do something that always happens after, which is kind of a nice thing. So you can
is
do
it just like another line right after it that just says finally?
That says finally, and that sometimes can mean, close a dialog window or call the next step or whatever else that you always want to do, even if there's an error. So there's the try, there's the except, which, either will raise an error or will give instruction or something else in case there's an error. And then the third piece is, and after all of that is done, finally do the following. So there's a third piece, but it's optional.
Okay. Did I do it right? I was just listening to you. I don't know if this is exactly right or if there's more to it.
I'm only seeing the book. Do you have an interpreter up? Or?
That weird stop share thing is doing the thing. Okay. How can I Okay. This. Can you see this?
Yes, I think that is how you do that. Let me double check though, because I don't do this very often. Let me just very quickly look it up. Yeah, so let me just pop a link in really quick. I'll pop it in the Slack channel for you so you can take a look at this.
Well, it looks like it did it.
Yeah.
Cool.
So if you look here at the finally clause is always executed before leaving the try statement. And so you can see here in the def divide by x comma y, there's a try, there's an except, there's an else even, and then there's a finally, which is kind of nicely laid out.
Cool.
Yeah.
So if y'all didn't notice, she posted that link in Slack. So if you want to expand on your error handling skills, we have a couple others to look at and play around with. Awesome. Thank you, Bethany.
Welcome.
Okay. And let's see. So that was our dividing. Okay, so now we can get to our programs that were at the end. Or that was actually the last bit of new information that he was showing us. He was asking us to actually put in a guess the number program, and he actually walked us through it line by line to explain why it worked and why you did some of the things that you did. I think some of the key takeaways, did anyone have any comments or questions about this program? Because he didn't really show anything new. It was just putting it all together.
That's what I really like about this though. If you notice under ask the player to guess, you see there's a for loop, and then within the for loop, he's got an if, an elif, and an else, and then he uses a break to get out of the loop. I really like that he was very, very clear in putting those pieces together.
So if you haven't had a chance to read chapter 3 and you're short on time, definitely at least jump down to this section. It gives you a nice wrap up of chapter 1, 2, and 3 pulled all together. But what it also does, what I liked was he started using these comments, because just from a good programming practice, it's always a good idea to explain what is the point of the code that you have in front of you. And for each little function or area or line of code, he throws these comments in so you know, why is this running? What is the point of this? Because you'll understand it the first time you run it, but I promise you, 2 months down the line, if you haven't touched it in a while, you're going to forget why you put a certain line in there. So just, you know, pay attention to these comments. So yeah, so he takes you through it line by line by line. And I didn't hear any questions on that. So if not, we're going to jump into the practice questions. And there's another practice program down below. Okay. Practice question number 1. Why are functions advantageous to have in your programs?
A function lets you group code that gets executed multiple times. You don't want to duplicate code.
Yep. Anybody else have an answer they want to throw out there?
I think that's a perfect answer.
Perfection. First time, I love it. When does the code in a function execute? When the function is defined or when the function is called?
When it's called.
When it's called, correct. So the definition could be at the top, but even though it's at the top of the file does not mean that it's actually executed. It's only until it's called. Okay, what statement creates a function?
Def statement.
Def, yep, D-E-F. And then it's always followed by the name of the function. So let me see if I can show a tiny bit of that. There we go. So here's an example of it getting defined. You have the name, or def, the name of the function, and then if there's any arguments inside of a parentheses. Parameters, excuse me.
And the switch off again. Sorry, I polluted everyone. I apologize.
No, that's just what I do. Like argument, no, I use them 100% interchangeably, like synonymous in my head. So whatever comes to the forefront. Okay. What is the difference between a function and a function call?
A function call runs the function that was defined in the def statement.
Correct. What is, so then
so
what?
one is like a blueprint and the other is like a widget in some ways, right? A
Like
function,
the actual thing.
yeah.
So here are little baby function calls. This one is calling this code to run. And this is the actual definition of the function. Okay. How many global scopes are there in a Python program?
One global scope.
Yes. Just think of it like the world. There's just only one. We're only sitting on one world, one broadcast going out. How many local scopes are there?
Multiple. You can have, I guess, as many as you want.
True. If you got a little bit more specific, how many local scopes would you say there are? It's equal to what?
Guess I don't know.
I would say it might be equal to the number of functions that you have that execute. So, right, because a local scope is always in relation to a function, and we only run function code when it actually is called. So every time that a function is called, you're defining a local scope. Okay.
And if we have time, or we can do it some other time when we review, we can go ahead and put that small program or one of these small programs into Python Tutor, and it will show you, it will label global scope and it will label local scope, and we can step through that. But let's get through the questions first, because I think these are really good questions.
Bye, Christina. Thank you for coming. Okay. We're getting to none, Lori. I haven't forgotten. Don't worry. Okay. What happens to what happens? Okay, yeah. What happens to thank you? What happens to variables in a local scope when the function call returns?
The local scope variable ends or is forgotten after the call.
Agreed.
Yep. Goes away. Blew it up.
What is a return value? Can a return value, wait, let's take it a piece at a time. What is a return value? Anybody?
Whatever the function returns.
Yeah, whatever you've asked to be, whatever value or values you have specified be passed out of a particular function.
Right. So you have to make sure to do that like return statement. Did we not do that? I feel like we
did. We scrolled
did.
through it, but it may be further up than. There we go. Return divide by. Right there.
Oh, there we
You
go.
look at the.
There you go. Just to make sure. I can't remember if I explicitly highlighted that or not, but a return looks like this. Well, that's actually in the error.
That's in the error, but yeah, there we go.
So you're returning out of that function a very specific value or expression. Okay.
Or data structure, you can return lists, you can return any object, and most things in Python are objects. But yes, in this case, that was a specific value.
If a function does not have a return statement, what is the return value of a call to that function?
None.
None. Woo! We are learning something today, let me tell you. So since we're on the topic of none, what is the data type of none?
Oh.
Untyped.
Data type.
None type, yes. I did not even know that was a
known as a singleton. None is none is none. It's always the same none. To be philosophical about it. In Python, there's only ever one in a program.
Huh. So Lori brought out something interesting from Stack Overflow. None is just a value that commonly is used to signify empty or no value here. It is a single object, singleton, like you were saying, Bethany. It only has meaning because the Python documentation says it has meaning.
I know, this is where you get just very, very, like, it's ridiculous. You read it out loud and you're like, what the F?
That's fantastic. Okay, how can you force a variable in a function to refer to the global variable?
Define a global variable.
How? What do we got to do?
Global keyword.
Global keyword. Got to throw our global keyword at the front of it when we're inside of a local function. Sorry, I always have to just make sure everyone saw that. Like this.
There, global statement.
That's what we're talking about. Okay. Let's get back. What does the import are all your pets named Eric statement do? What does the import statement do?
Imports a module.
Correct. And as a reminder, what is a module?
I'm going to think of it as a library.
That's one type of module.
I guess I don't exactly necessarily know. I just always think of it like external code. Like code that is not in my code, I'm just going to go borrow that and pull it in so I can start referencing these functions that are in that library, if you will.
That is a perfect definition. And I think that's the point of question 11, is that it can be that external piece of code can be as small as a function or as large as, millions of lines of code. That Python considers anything that is executable, nameable code as a module. So when you import, as long as it's accessible at the time that it reads the import statement, then you can pull it into your code.
And yeah, I lost my thought.
Oh, I'm sorry.
No. It wasn't that great anyway. It's all good. Oh, that's what it was. Black box. We sort of skimmed. We didn't actually talk about it at all. This is what I imagine like black box. So when people say black box, it's essentially like you're just bringing this code in. You have no idea necessarily what the code. I mean, you have a high level idea of what the code is doing, but you don't see that code in yours. You're just referencing it here. Say, hey, whatever code that is, can you bring it in here? I have no idea what it is. It's a black box, but I know it's going to bring me something that I want. I think the most common one that we've used is random, importing the random module so that we can do like random integers and things like that. If you had a function named bacon in the module named spam, how would you call it after importing spam?
Spam.bacon parentheses.
Right. So spam is the module name with a little dot, and then you just call the actual function. Cool.
So as a add-on to 11 and 12, you can have a module named spam, but what you can also have is a file named Bethany's spam tidbits with a function named bacon inside. And what you would import would be the name of the file. So module's a loose thing.
Okay, so that was the file name?
Right, and then any functions that, if it can access the file name and import it, then any functions in it would be then the name of the file dot the function.
Bethany tidbits spam
And
or dot bacon.
right, and I want to specify that Bethany tidbits file would need to be a .py file, not a like txt, because it has to be recognized as Python code. So it has to have real Python code in it, clearly. But yes, that's, and you can do lesser or more elaborate packaging that's way further down the line. But essentially, that's what Python allows you to do. You just say, hey, there's code in that file over there. It's Python code, and I want to use it in my file. So, go over there, find it, bring it to me, read it into the namespace so I can use it.
Got it. So it could be a file name or a module or any variety of things that Python lets us import.
Yeah, or a library, or an SDK. There's schmancier and schmancier names for it, but really, like you said, at its root, it is Python code that you may or may not know anything about that you want to use in your program. That's from somewhere else.
Cool.
Yeah.
Okay, how can you prevent a program from crashing when it gets an error?
Exception handling.
Exception handling called try and accept. Well, I think that's an example of exception handling. There's probably others, but that's the one that we learned in this one.
Yeah.
So what goes inside of the try clause?
The code that potentially can have the error.
And then in the accept?
How to handle it if an error occurs.
Yes. What to do when things go wrong. Okay, cool. That's all of our questions. Any questions about the questions? Okay, those last little bit was the practice project. Did everybody have a chance? Did anyone have a chance to do the practice project?
I did it, and it doesn't work. Mine doesn't work. Can I put my code into the Slack?
Do you want to share your screen, or do you want to? I mean, I'll take it from the Slack, but if you want to share your screen, that could be.
I don't know how to do that.
Okay.
Let's see more. Oh wait, I don't have the program on this screen. I'm talking on a little
Oh,
pad thing.
okay. Well,
It's a Samsung pad thing.
we'll try
Um,
putting it in the Slack and let's see how well it copies over.
Okay.
The other thing we could do, and I don't want to bogart this session, but if you go to pythontutor.com and paste it in there, we could start a group session where we all have access to the code if you want to try it out. Otherwise, we can.
Ooh.
Okay, let me go there.
Okay, so,
Python.
and this is Lisa speaking, right?
Yes.
Okay. Did anybody else have any problems with their code? And they want to take a look at theirs too? Just checking.
And how do I'm there at Python. How do I, let's see, visualize your code and get live help now?
Okay, so what you want to do is you want to go to, I'm sorry, let me just pull it up. Yeah, click the visualize your code and get live help now. That will take you to a place that has an empty box and it says write code in, and you want to select Python 3.6.
Python 3.6. And how will you all be able to see?
You should be able to, let's see, let me just give this a really quick test. Yes. If you click the button that says start private chat, then you can give us the URL and we can join in once you've pasted the code in. So in the upper left-hand corner of the screen, there's a get live help button and there's a start private chat button. And you can press the start private chat and then it will give you a URL to give us.
It's very long. Do you want me to read it out or?
Put it in Slack.
Paste it into Slack. Yeah, paste it into the Automate the Boring Stuff channel.
Okay, and let me go to Slack.
So just for anybody else on the line, we're going to go through the code. That was the very last piece of the Automate Chapter 3, Automate the Boring Stuff Chapter 3. We're going to go over the collat sequence, which just goes through a little, you input a number and then you work your way all the way down through 1. And he gave us a prompt, and so we're looking at some very unique code to figure out, to see if we can get it working. If you don't have any other questions, you're totally welcome to go have a good evening or good morning, whatever time it is, wherever you are. That's all we have for today. But we're going to stay on the line and work on some code for a little bit. Did anyone else have anything else if you are about to leave? And one more thing before you leave. Next week, we will not be doing Chapter 4. What we're going to do is give anybody a chance to review. So we'll be going over Chapters 1 through 3 again. We're not going to go over Chapter 4 next week. There's probably going to be there might be a review session next Thursday at the same time. So if you want to come back and practice, or if you just need to take a week off, that's what we're trying to put little breaks in the schedule for. So just as an FYI.
Yeah, and we're not sure who's going to be hosting. I probably am. And what I'll just do is we can quickly go over notes or just leave it open for any questions or issues someone might have, or little programs you want to go over or code that you want to go over. But like Jamila said, we're not going to go over Chapter 4. We want to make sure you have time to absorb all of this stuff and give yourself a breather.
But the week after, we'll be back. So just keep that in mind.
Okay, let's see.
Okay, so y'all can go if y'all do need to, but please stay if you can.
I am pasting the link in.
Awesome.
And enter. Okay.
Cool. I'm going to go ahead and click on that right now, Lisa.
Okay. And I am typing in my code. Let's see. number, modulo, 0. Number.
And Bethany, do you mind sharing? Because I think I'm behind a firewall, so I might not be able to see the chat.
The chat window, or
Yeah, it looks like it's throwing me some errors, the whole website, just because I'm behind a firewall.
Oh, that sucks. Okay, yeah, let me do that. Hold on, it's going to take me a minute to fumble around. Remind me, where do I share?
I think at the bottom of the screen, like if you put your mouse at the bottom, it should show up, and it has this little green box that says share up.
Okay, I'm not actually seeing that. All I'm seeing is chat, raise hand, and Q&A. Do you need to stop for me to... Why is that not working for me? That is so weird.
I don't see it either. It was like a little green strip, right? That you could.
Yeah, that's what I thought. Is it at the top of your screen by chance? Like if you hover over at the top? Maybe it's the setting of this particular webinar. But I felt like we could share before.
No, because I saw the share for you and I saw your screen, and at some point we switched, and I don't know if that was, Lisa, did you have sharing on at one point? I wonder if there's like a...
No, I don't know anything about sharing.
Huh. Okay, let me look at the tab. I've got a tab open on the browser as well that has this.
Here, let me see.
Ah, there we go.
Well, that's my sharing.
That's your sharing.
Yep. So I don't see a way for me to like hand it off.
You're viewing so-and-so's screen.
Oh, wait, hold on. Hey, are you still there,
There
Bethany?
we go. Now I see share.
Okay.
What did you do?
So apparently everyone's an attendee, and so I promoted you to a panelist.
Oh, yes. So those settings are the ones. Okay,
Yeah.
so let me share this.
Okay, I'm going to stop.
Okay, so I am going to do that, and then I am going to share desktop number 2, which is this one. Can you see that?
Yep, got it.
Okay, cool. I'm going to close this chat window because it's distracting. Okay. So have we looked at Lisa, have we looked at the execution of this yet?
No, let me see. I can do it one time and then it kind of dies. Let's see.
Okay, so if you press the visualize execution button, let's step through it and see what's going on.
Visualize execution.
Okay, and then if you notice down here, there's this forward button. This is going to step through it, and then the red arrow is going to show you what line the interpreter is on as we go through it. So type a number. So we need to type in a number. I don't know, what, 12?
12.
Try
12?
That's
or
fine.
13.
13?
What do you suggest, Jamila?
I was going to go with 3 just because I think that's the one that's in the book.
Okay, let's do 3.
Yeah.
3. Submit.
Okay, so if you notice over here, look at this, over to the right, global frame, there's collapse, which is the function, and then you've got a number, 3, right? So that's your global variable, number 3.
Oh, okay.
And if you notice, there's quotes around it, so it's a string. Okay, so if we step forward.
Forward, okay.
So, that's cool. So it's no longer a string.
Integer.
Okay, so now we're on line 15. So if I go forward one more time, now we are starting our function.
Okay.
All right, now we're on line 2. Keep going.
Forward.
Ooh. Question. Should
Okay.
she have
Can we talk
I just
about
noticed that these
Oh.
are the same name,
Okay.
global and local.
Global and local.
Yeah. Yeah. You are shadowing. So one thing we might want to try is renaming either the global variable name or the local variable name, just to make it absolutely clear which is which.
Yeah.
My global, which line has the global
13. So you see how the execution started, the whole program started at line 13. And you declared this variable here called number, and that became your global variable, number.
Okay.
But then you started using it locally inside of colats. So I haven't like walked through every single piece, but I'm worried that something's about to happen here because you're assigning it to at a local level, even though it's a global number. And you're trying to actually do something different at the local level. So in line 13, 14, and 15, it might be worth changing that to another name, a global version of that variable.
What I sometimes like to do with things like this, because I know that this, right, literally on line 13, you have input. You can do something like input underscore number equal input, right? So that you know that one of them is an input number and one of them is a number, if that makes sense. So if for a sec we go back to click edit this code, I can show you really quick. Here, if we just do...
Oh, that's great. You can type in.
Yeah, this can be a little chaotic, but I also like it because we can all collaborate on it at the same time. So maybe that way.
Now, does she have to, she has to keep going, right? Like,
Yep.
And the
But
one
this
above?
one you don't, because that's just a variable name.
Right. No, number 14. I'm on row 14.
Oh, yes. Thank you. Good eyes. So let's give this a try. I don't know that we found everything, but
Three.
look what happened.
I think it's supposed to return 10.
Mm-hmm.
But then after that, then doesn't quite work.
Really? Because it looks like it does.
Woohoo! Keep going.
Yeah, do another one. So what you can do is you can back up here. First of all, it'll show you all the steps in reverse. which I think is kind of cool. So you can walk backwards through, but you can also start over and do another input.
Wait. Hold on. Maybe I'm misremembering this. But isn't it supposed to go all the way down to 1?
Yes,
So it just stopped?
yes,
Was that the problem you were having?
yes.
Okay, so this is supposed to recurse?
Mm-hmm.
Okay.
Oh, I see what's missing then. Okay.
A counter?
It's, okay, so what have we learned that allows us to do something again?
A loop?
Yeah, we need to get into a loop. So
Ah, yes. No, that is very
we
smart.
have a couple of options. Like what are the types of functions that we can use that allow us to loop?
Something about
General question to anyone.
While or for?
While or for. Those are 2 good options. So I think that the prompt on this one, according to the book, it says, then write a program that lets the user type in an integer and keeps calling that function on that number until the function returns the value 1. So that's how we know we stop, is when the function returns the value 1.
right, and that's why I put that else statement in there. Else number equals 1, then return 1. But I guess that's not what you need. You need a loop.
Yeah, so it'll keep going through numbers. You need that loop in there.
Right. So because the only way, think of it like this. What it's trying to do is it's trying to do these calculations in this function where it's dividing it by 2, or it's timesing it times 3 and then adding 1. It's going to keep doing that over and over and over again. So we want it to keep doing that until eventually the number whittles its way down to the number 1. So this whole colats part needs to be inside of a loop so that it keeps going through until it hits the 1. So the way I did it was I used a while loop because I wasn't sure how many times it needed to go around. So I kept going until I saw that the number eventually equaled 1, and then I stopped.
So I'm going to click edit this code. Where would we put that while loop? And I'm happy to type, or I'm happy to let someone else who's in this session.
I'll let you type.
Okay. Where do you think we would put? And does a while loop sound like the right loop to pick? Jamila picked a while loop. Does that seem like a reasonable choice?
It sounds good.
Did someone choose something else? Because that's just what came to my head.
While whatever variable is greater than 1.
Or maybe while that variable is not equal to 1, because it's only when it's 1 do we want to break out.
Okay.
So which number are we talking about? Are we talking about input number, or are we talking about answer?
Could it be the input number? Like that's the number that you're asking them to guess?
Until the function returns the value 1.
Okay, so while input number is
Input number
greater than?
Could be as long as input number is not equal to 1, then you want it to keep looping. Because once it hits 1, you need to break out of it.
Okay, so this, or do we want to do this?
That.
That looks
That,
good.
okay.
I do have a question about why did we use the regular number word in line 1? When we, on number, let's see, when it calls the function in number 18, we use input number, input underscore number, but in the definition, it's a number 1. In line 1, it's class number.
So is your question, why did we change it? Why are they not the same?
Yeah. How is it going to understand to put it into number?
Oh, okay. It's because of the call. So when you look at line 18, colats open parentheses, it's not actually passing input underscore number. It's actually passing the value assigned to input underscore number. So if I type in the number 3 into input underscore number, line 18 is taking the number 3, not input underscore number. It's taking the number 3 and putting it into this on line 1. It's putting the value 3 into this newly defined local variable called number.
Got it.
Yeah, so let me just really quick, just to solidify this. This is why I really like Python Tutor. If I'm going to comment out line 13 because we started a while loop here, but if we go back to visualize execution, you can see this here when you see Python read-in. Whoop, okay. You see Python read-in, it says, okay, I have a global frame, right? Everybody all over the world. And I've got this thing named input number, a box named input number, and in that box is this. Then we go to the next step and we say, no, really we wanted that to be a number and not a string. So this is already in the worldwide definition that input number is a box that has 3. But then what we're telling the interpreter to do is to have this thing on line 18, answer equals a call to the function with whatever was in the input number box. So notice, now we've got this thing in the collat scope, local scope, that it got from the global scope. And so now it's calling its local variable, which happens to be named number, and it's putting 3 in its local box. And that's why Jamila and I wanted to rename this, because this belongs to global scope. This belongs to collat scope, to the local scope. So we're passing it from the global to the local to make sure there's no confusion. And the reason we want to do that is because you are reassigning the value within the function, right? And so you don't want Python to get its panties twisted because you are reassigning. So you want it to stay local. So as you go forward, now it has passed 3 from the global to the local into the function. And now this is in the local scope. And notice, it did the calculation and it reassigned the value, but only for the number that we're referring to in the function. It did not change the input number, which is in the global scope. And that's actually what we want, because we only are concerned with what's going on inside the function, right? And so then it's returning out 10.
One other question on line 3, when you do the division, you have to insert an escape character.
This is an interesting thing. So this is a difference between Python 2 and Python 3. Python represents all of its numbers as what's called floating point numbers. It makes mathematicians and scientists insane because it is not consistent from machine to machine, and it has millions and millions and millions and millions of decimal places. And so in order to tell Python that what you want is a round number with no decimal places, you use the // for division. If you don't do that, it will return you a floating point number. And we don't want a floating point number in this circumstance. But what used to happen in Python 2 is that division, normal division did that. And that's not cool either. You don't expect normal division to work that way. So they redid it. So you do a // to tell the Python interpreter that once it's done with the math, all you want is everything to the left of the decimal place, and you do not want any of the decimal places. So it's called floor division. That's what the // is for. I think there's in a minute, I will look up the documentation does a way better job than I do. my words are not great when it comes to describing the difference, but that's what that // means.
And I think it was in chapter 1 or 2. Let me see. Yeah, it was in chapter 1, in the little table, and I'll put it in the Slack channel so that you can see what it's doing.
Yeah, it's interesting to look at the differences of those things. And for a lot of stuff that you do math-wise for like general purpose programming, you can be a little loosey-goosey, but when you start to deal with money, when you start to deal with anything that takes any sort of precision, right, certain number of decimal places, then it starts to matter a lot. And when you get into statistical applications, this is where you start to need to import libraries that other people have written because they were driven insane by the way Python handles numbers. But libraries like NumPy and SymPy that allow you more control over exactly representing numbers the way you need them represented. Because if you're dealing with like global coordinates, or you're dealing with, percentages when you're calculating acid water mix or whatever it is, yeah, you don't want the behavior to be unexpected. So anyway, alrighty, should we go back to editing this and write our while loop? Or I'm sorry, I should have waited until somebody told me that they had their questions answered. Let me do this again. I apologize. All right. So are there any other questions before we go back to writing our while loop?
No.
Okay. I'll click edit and I'll uncomment this. So what do we need to do inside our while loop? Ooh, is it really while input number?
It's while the return value, the return number.
So would that be answer?
Answer, yes.
Okay. All right.
I think you can get rid of my else statements. The else number equals 1.
So line 10?
Yes.
Okay. Do we want line 11? Or do we need line 11? I guess we've got line 4 and we've got line 8, right?
Mm-hmm.
Okay, so let me take line 11 out.
While answer is not equal to 1, we want it to keep running.
We want it to keep running and we want it to keep printing.
But what do we want it to keep running?
Colats.
Okay. But what would be the argument to colats that we would use every time we go around?
User's input, right? Like looking at that, whatever was input, and it keeps, I don't remember what the collat sequence is, but.
Well, not initially, we want the input, but going forward, we want answer. Because we're slowly whittling down the number.
Okay.
So I'm thinking.
So do we want to take line 19 out?
Mm-hmm.
Okay.
Or, how do I put it?
And this needs to go inside of the while loop, doesn't it?
Yes.
Okay. So I'll put that here.
I think we need to assign input number to answer. So I think that I think 19 needs to be inside the while loop. Or, okay. Hold on. Let me rethink this. Well, the while loop needs to be, first of all, below type in a number, right?
Mm-hmm. Okay.
Like lines 13 through 15, yeah, should be after we've input the number. Because we're taking that information. There we go.
Ooh, so.
There we go. Mm-hmm.
And then we want to call
colats
with.
Yes. Or, let's see.
But then we need to update that global variable each time through, wouldn't we? Because answer needs to change each time.
So answer equals colats answer?
Well, but answer's global.
That's okay.
Okay. So,
because we're taking the output of colats, putting it back into colats.
Right, but don't we need to update this because we're going to need to do a check? Otherwise, our loop's never going to end, is it?
Wait, are you trying to say that this answer that we have on line 20 is local?
No, I'm saying that the answer that we have on line 20 is this answer. But we want to update this answer, correct? So if we don't put global here, what happens if we try to reference this? Actually, you know what? Let's just do that. Let's do this and see if that works. Shall we give it a try?
Let's.
Okay. So that seems to be working. Now, why is that?
Oh, we have a problem. It didn't print 10.
Okay.
It should
So
print.
we need to print at least once then, yes? Here? Or do we want to print,
Do we even need line 17?
Yes, we do. Otherwise, we won't get an initial value. Although we could.
Well, we're assigning the initial, because I was thinking we were assigning the initial value on line 22.
No, we're assigning it here, right? So if you look.
I guess I meant if we didn't have line 17.
We could give it a try. But here is where, right, so.
It goes up. Oh, should we be printing in collapse?
We could.
That would make sure that we get the 10. Because what's happening is it pulls out that very first number. The 10 gets lost when it returns back to the global. It doesn't print the 10 because that function was done outside of the while loop.
Except if, give me just a sec here. I want to see something.
Yep.
Just do this really quick.
And just for the record, each time you return a number, you should be printing.
Well, you can either print inside colats, or you can have colats return the number and you can print outside colats.
Mm-hmm.
So if you notice now that print is on line 21 and answers on 22, we have printed 10 first.
Spiffy.
Yeah, so it's an order, right? It's an order of operation because it's asking right here, print is saying, what is the current value of the global variable answer? And it happened to be 10 because we haven't changed its value. We change its value on line 22. So now when 22 executes, all of a sudden, right, it's passing in 10, but now that value has become 5. So now when we hit the while loop, the value will be 5.
Okay, hold on. Lisa, are you following?
Let's see. Okay, you see, you commented out 10 and 11. 17 is confusing. Line 17 is confusing. You put in the input number, and that's equal to answer. And then while answer, okay. But then number 22 that's confusing.
Like why we have a line 17 and a line 22?
Yes.
So let's edit this code and let's do this. And then we will do, but then what do we do? So if we don't set the value of answer, or actually let's do this instead. Rather than a function call, let's give this a try.
Okay. Yeah. What you call
So
that?
then let's take this and do this. All right. So if we try this,
So Lisa, we're taking the input number that that person put in, the 3. So at this line here, we have that number as input number, but we're going to assign it to answer because answers is what we're going to fiddle with inside of this function.
Right.
So we've assigned it to somewhere else. So we're going to take this answer. So it's not a 1, so we don't have to end it. That's why we're going into the loop. So we're going to keep doing this whole function until we get to 1. So on this line, this is where we're about to go into the function.
All right, so notice, now we've gone from global to local to calling the code that is in Colapse. We're calling the code with 3. Well, it's not an even number. It is definitely an odd number. So we're going to take and reassign a value of 3 times our value plus 1.
10.
10. And we're going to return it. But where are we returning it? We are returning it to the code that called our function, which is
21.
here on line 21.
Yep.
And then the next thing we're going to do is print it out.
And then we start the loop back over because
With a 5. Yeah.
that number is not 1 yet.
Wait, did you input a new number?
No, the while loop doesn't need to. It's just taking the number that it already had, putting it back in. So that it took that 10, put it back into Colapse, and now it's whittling it back down.
And so now, again, we have a return value, and this time the return value is 5.
So watch. Okay, so you see how answer is now 5?
Yes.
So when the loop happens, let's do the loop. Answer is still 5. It's not 1, so it's going to go down to line 21. The 5 is going to pass inside of Colapse. And so we're going to start this function over with that number 5. And hopefully get to 1 maybe? Let's see. No, 16.
And yet, mathematically, this is crazy. There is, if I can find the link, I'll post it. Mathematicians like to draw trees, like trees with branches with this, and it always comes back to 1. It's just a matter of how many branches are in the tree.
I think I read in the book, it said they don't know why. No one knows why. When you go through this little loop, it always comes to 1. But eventually it will.
Well, now we've got 8.
That's even.
If you notice where she's pressing forward to the left of that, see how many more steps we have? It's going to do this for a second.
Although we can skip to the end if you want to know the end of the story. Although I want to see all the steps because I don't believe that it's actually going to happen.
Okay, so you
now
you think,
it's gone from odd numbers to even numbers.
huh. Does anyone have any questions about the process that it's going through right now? And or just from not a mathematical perspective, but like from the programmatic perspective?
Okay, so it's not going to go through 15, 16, 17 anymore. It's only going to work with the numbers it already has.
Right. Well, okay. It's just doing, the only math it's doing is on line 3 and line 7. So whatever number that happens to work out to, it's going to work with that number.
Look at that.
Ooh, we got a 1.
Ladies, we have a 1.
Now,
and now? What? We're
now
done.
we're done. Oh, spiffy.
That is spiffy. But what is interesting to me is that we didn't have to use global here. I wonder if that's, you know why?
I thought it was because we were still in like the global portion of the program.
We are in the global portion of the program. This is not inside of a function. That while loop is outside of a function. Very good. That's why we didn't need global. Because it is global.
Oh, that's awesome.
Yeah. Lisa, thank you. Made my brain work today.
So it's just a tiny tweak, Lisa. All we did was we commented out those 2 lines, and we added a while at the bottom.
Okay.
And we moved our call. Notice how before answer called colats up here. Now instead answer's calling colats inside the while loop.
And I no longer have global and local variables with the same name.
Yes.
Yes.
That's true too. Very key.
I'm trying to think, how can I save this? Is there a way for me to save it in this program, or no, I have to copy it?
You have to copy paste it out, but you know what? Another member.
Bye, Lori.
I'm sorry, what?
Oh, sorry, I was saying bye to Lori.
Bye, Lori. Thank you for attending. Another member suggested, was it this morning or yesterday, that we start a repo with code snippets. So maybe that's what we should do, is we should start a repo with code snippets on GitHub.
In GitHub. Oh.
So I'm thinking, tell me what you think. We should have like a Women Who Code Python code snippet GitHub, but maybe going forward, we all should have our own GitHub. That way we start building up our experience with using GitHub, putting in our own code there so you can play with it. We could practice forking from the Women Who Code Python into ours, all that stuff.
Ooh.
I'm signed up on GitHub, but I haven't used it yet.
So maybe that's another tutorial we have or something. What do you think?
Oh yeah, having a jam on Git and GitHub would be great, and I so could use a refresher, because that stuff is. I don't know if you saw. Probably not. I probably didn't post it. There is a very, very funny XKCD cartoon that actually. Let's see if I can pull it up really quick. Yes, this one. This is Get. It tracks collaborative work on projects through a beautiful distributed graph tree theory model. Cool. How do we use it? No idea. I just memorize these shell commands and type them to sync up. And if you get errors, you save your work elsewhere, delete the project, and download a fresh copy.
That sounds exactly like what I would do. Yep. I have no idea how
That is what I did for the first year of using Git. That's exactly what I did. I think what I love, the tooltip is even better. Let's see if I can get it. Yeah, if that doesn't fix it, git.txt contains the phone number of a friend of mine who understands Git. For a few minutes of it's really pretty simple. Just think of branches as, and eventually, sorry, I can't find it. And eventually you'll learn the command that'll fix everything. So anyway, it's not as terrible as all that, I promise.
But yeah, it's not the most straightforward thing in the world.
Yeah.
So.
But I am happy to, since I have this up on my screen, and I was supposed to put together a snippet repo anyway later today. I can put together a snippet repo, and then, yeah, maybe we can set up a session sometime where we all play with Git and forking a repo and pulling stuff into our repos and doing all that. Does that sound good?
Yeah.
Yep.
I signed up for a Udemy class for $10 on the GitHub, but I haven't started it yet.
That is awesome. GitHub also has really nice docs. And what's also really nice about GitHub is they have some really nice how-tos based on, you know, whether you're on a Windows machine or a Linux machine or different things like that. Like there's different clients you can use and different ways of proceeding. So, yeah.
Cool.
Hey.
Well, does anyone have any other questions while we're here about Chapter 3 functions?
No.
Well,
I
thank you,
just
Lisa,
think, well, because there's nowhere else to get the answers.
Well, we're here. That's what we're here for. It's going to be great. We're going to learn all together. I love it.
Yeah.
So as a reminder, next week, you're welcome to read Chapter 4. We won't be here discussing Chapter 4, but hopefully, yeah, somebody will be here and we can just review just general stuff. Or if you just want to take a break on your mind, that's fine too. But we will be back the week after next discussing Chapter 4. And I hear that Chapter 4 might take a little bit of work, so go ahead and maybe get a head start on it. Don't put it off to the last minute. I have a bad habit of doing that. So
Me too, but
I'm telling myself that.
this is not the one you want to put off. So, yeah.
Chapter 4, it's going to get serious. Okay.
Cool.
Thank you.
All right, and I will post a link to the repo as soon as I get all the details sorted.
Yep, and I just posted the notes as well, guys, for Chapter 3 if you want to just read over it at your own leisure. And you can also add notes to the stuff we have up there. But that's all we have for tonight. Everyone, have a good night.
Thank you.
Thank you so much for hosting.
Bye.
Bye.